A perhaps more realistic model for many things that we think of maybe as exponential is a logistic growth model. And logistic growth models are where we have a quantity, usually a population, that is growing or sometimes decaying. But the way that it grows, we would normally expect exponential growth. However, there's a limit to how much it can grow. There's some external limit. And what we end up with, I'm going to go and draw a picture of what that looks like. Okay, so exponential growth, starts to grow slowly. Oh, let's try this again. Starts to grow pretty slow, and then it speeds up. But with logistic growth, after it speeds up, it's going for a while, but then there's some amount that we can't actually get over. Like it's sometimes called the carrying capacity or the limit to growth. And we can't get there, so we have to kind of start to slow down and start to kind of level out because we can't pass that up. Okay, so this is an example of logistic growth. This is very common for modeling populations. For example, some species of animal in a certain ecosystem. Generally, they would grow exponentially if left unchecked. But if they are prey to some other predator, then the predators will stop them from growing too much, and or maybe the food supply is not enough to sustain unbounded growth, and so it'd have to slow down. And there's kind of that limit, that limiting value. So this is what a logistic growth model looks like graphically. The equation here looks pretty complicated, and we're not going to worry about all the little things here, but an important thing to know is that that's the limit to growth. That's the upper bound on how much we can grow. And R is just some growth rate, and then B we can determine using our initial size. And I'll write that here, that the initial size is A over 1 plus B. Okay, because if x is 0, then you get e to the 0, which is 1. Okay, and then you just have A over 1 plus B. A quick comment about this number e. E is a special number. It shows up a lot in applications, such as logistic growth. And it shows up so much in nature that we have given it its special name, which is e. It's kind of like pi, in that pi is a number, 3.14159 forever, right? And e is similar. It's a number that starts out 2.71828, and it goes forever and ever and ever. Okay, it's a special number that shows up a lot. So we've got e there, and most calculators will have a button specifically for that e, just like they have a button for pi. Let's look at an example. On a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by this logistic growth function, where y is the total number of students infected after t days. How many students are infected after 5 days? That just means we're going to plug 5 in for t. So we get y equals 5,000 over 1 plus 499 e to the negative 0.8 times 5. Okay, and so this we can go ahead and just plug into a calculator. So we've got here 5,000 over 1 plus 499. And then for my e on this calculator, there's a button right here, e raised to something. So I'm just going to hit that. E raised to the negative 0.8 times 5. And I'm going to go ahead and get that number. Now, we are talking about number of people infected here, so it doesn't really make sense to use a decimal. So I'm going to round this to the nearest whole number. And I get 493. 493. This is a pretty fast spreading virus. For Part B, the college will cancel class when 40% or more of the students are infected. After how many days will classes be canceled? So 40% infected, that means, well, that's 40% of the 5,000 students. So let's first figure that out. That's 0.4 times 5,000. And that's 200. Okay, so once 2,000. Once 2,000 students are infected, they're going to shut down classes. So now we're just going to take this thing and set it equal to 2,000. 2,000 equals 5,000 over 1 plus 499 times e to the negative 0.8 times t. And we're trying to figure out what t is. Now, there are ways to solve this by hand with lots of different tools, but this does say use a calculator to solve. So we're going to go back to our calculator and see what we can do. Now, depending on your calculator, you may or may not be able to solve it. So calculators that have CAS on it, that stands for Computer Algebra System, meaning it is able to solve equations for us, which is really, really nice. There is a free Computer Algebra System calculator actually available online. That calculator is the GeoGebra CAS calculator. So if you go to geogebra.org/CAS, this is a calculator that will do that for you. I'm going to go ahead and now type in how you do this. So the syntax of typing this in can be a little strange, maybe. We're going to type in solve, okay, and it says, solve, and then it says, okay, I'm going to solve an equation, and we're going to go and type the equation in. 2,000 equals, and then I've got 5,000 over 1 plus 499 e raised, sorry, I messed that up, sorry, e raised to the negative 0.8 t. Now, if you just hit solve here and you just do it, sometimes it'll work out for you, and that's really nice because there's just one variable there to solve for. But you'll notice it gives this crazy formula, and that's not super useful to us. But if you click this little approximate sign here, that'll give us a value here. So t is about 7.26, and so that means that after about 7.25 days, classes will be canceled. So t is about 7.26 days. So after about a week, classes will be canceled because of this virus.